We are here today with you as a guest speaker on a very important topic. If the previous session was important, we were talking about a key component of the KNX IoT extension ecosystem, the thread mesh network. This topic is even more crucial because we are talking about the open source stack that enables the whole KNX IoT ecosystem. So the open source stack is a new approach from the KNX Association to enable KNX over IPv6 networks. It's the first time the KNX Association makes available an open source stack. So this is very new for us, and this is a new journey through Alex. And we've been now reaching out to new people joining this journey with us. And Alex is one of these persons. So welcome, Alex. We met not long ago because you are working with Passive Energy, one of our startups and members. And you've done an amazing job in adopting the open source stack and learning, understanding how it works. So the reason why you're here today is to share with our members, our community, what you've done so far and how you can open up new cooperation channels with the community. That's the beauty of open source. So I'm going to leave the stage is yours. You can share your screen. You can take over. And yeah, looking forward to your presentation.
Okay, so let's share the screen. Let's see how this is going. Go.
Yeah, we see your slide.
Yeah, I see, but I see a bit more than I wanted. I just wanted to have the slides as is.
If you put in presentation mode, running slides.
Yeah. If I put it in presentation mode, then I have the presentation on my screen.
Yeah.
But we don't have it on the big screen, you know.
It is fine as it is. If you want to go ahead like this, it's fine. It's up to you.
We don't find another solution, we will have to take it, but I would prefer to give it a try.
If you put it in presentation mode, you will see the screen, but it's fine because you can actually run the. Okay, just give us a minute, please, to get this up and running. One second while Alex is trying to get this sorted. We are almost there. Almost there. Okay, so you can share your screen, even if it's the slide deck. It's absolutely fine.
So we just tried with the entire screen, and let's see how this is going. Does it work?
Okay.
Finally, okay, we have it.
Good.
Okay.
Okay.
So then jump right into this because we don't have a lot of time and it's a lot of topics. So, well, my name is Alexander Burger. I'm based in Vienna in Austria, and I have an education as electrical engineer, and I'm self-employed. I'm a consultant for companies, and nowadays I'm working mostly on prototyping and on embedded devices. And this journey brought me to a company in beginning of the year. It's called Passive Energy. So Passive Energy is a company. They're based in Japan. They are doing home ventilation systems. The idea is that they have very modern ventilation systems. They are using a setup where you can combine multiple fans to work together. That's one of the USPs. And the other one is that they have a very high efficient recovery for heat that gets transported. So everything is very efficient. And at the beginning of the year, they thought they want to change their current product status. So what they had until right now is that if you have a home and you have multiple rooms and you want to have exchange of the air between the rooms and to the outside, then you need to build a setup where the fans are working together, where let's say one fan is taking in and the other fan is exhausting the air. You can do it also the other way around, and there are different modes you have to address. So those fans need to communicate with each other. And this was done until now in a system where each fan got a cable and you had a central controller and everything was controlled from one point. So the new series should be able to reduce the installation costs and to save time on installation. And also it should be controllable over a standard user interface, which should be state of the art nowadays. And since everything now is running on smart home, also a smart home integration should be done. So the new series, as you can see here, should get an app, and you should also have the interface on the device. That's a small LCD, but it's big enough to handle the modes you need to do. And normally you should be able to just integrate it in your existing home automation system, and you can control it from there. So what were the options for the new product? So you could go the standard twisted pair route with KNX, and we tried it at the beginning. And I was talking to some companies, and at the end of the day, it turned out that the KNX TP stack would cost us around 30K, and it was closed source. And we were going to build the system on ESP32s for a couple of reasons, which I will explain a bit later. But I needed a solution that would work there. And the problem is there is no existing solution, which I know of, that could work with our ESP32s. So this was not a good route, and we had to find a better way to do it. So we decided to go into a solution that's working wirelessly in a mesh solution. The first thing we tried out was doing a mesh network with a proprietary solution that's done by Espressif with the ESPs we were using. It's called Painless Mesh. This was done by another company. They made a functional prototype. It was working. The problem is that the library that was used had licensing problems, and so we ended up in a state where it was not the appropriate way to use that library. The other thing is that if we are doing a wireless mesh solution, we also need over-the-air updates, which is not in the standard implementation that's called ESP now. It's also done by Espressif. So this was also not an option. So after looking more and more into this and being to some fairs this and last year and Thread being hyped all over the place, I took a closer look at it. And from a technical point of view, I found that it's a very compelling solution because Thread has a few points. They are very, very interesting, which I will come to later. So, and after a comprehensive analysis of the rest of the system, KNX IoT looked also as a very good option. The only thing is there wasn't a lot of software out there at the moment. So the things were waiting a bit, and there were other things that had to be tackled first. So we now came back to the KNX IoT solution. So as in the talk before, thread was already explained, so I can keep it briefly. The important part about thread is from implementer's perspective point of view, that thread gives you a very robust mesh network that has all the bells and whistles you need. So you can do your over-the-air updates. It's based on the standard IPv6 and UDP protocols. So everything is there, what you need to do communication, even on small microcontrollers, because you normally always have UDP and IPv6. The other thing is, if you are in a building, you need a good penetration and you need to have a long range. So microcontrollers are normally not known for their high data throughput. So we are not sending very big data packages. So what we need is a low bandwidth protocol that's robust and that can penetrate the walls if we're in a building. So, and thread gives us all of that. So, and that was really great. And the other thing that was really great to see is that there is an open source implementation of thread that's called OpenThread. And there's already existing implementation for the ESP32. So that was really, really compelling for us. And this is why I got more and more into reading in that kind. And now we ended up with KNX IoT. So we joined the KNX IoT startup. And then we had to go a bit more into KNX. And the thing is, when you look into KNX, KNX is there for a very long time. So the system grew over the years, and that is the reason why there are a couple of different methods how the devices can communicate with each other. You know, at the beginning, there was KNX IP, TP over twisted pair. So this was the start of it all, but the bandwidth is very low, and it's not so that everyone has a twisted pair installation in the house. So then there came KNX IP, which is IPv4 based. And then you could work over Wi-Fi, and it can also do it in normal homes and not only in big installations. So, and now we get into the wireless solution. So when we look here and at the right-hand side, we have the thread network. And in the thread network, we have our KNX IoT devices. Then those devices are talking over a specific protocol. No, sorry, not protocol, over a specific protocol thread. And the thing is, you need to convert those packets then to a system where you can get it back to your standard KNX TP installation. So for that, you need basically two important things. You need a thread border router. So for every thread mesh network you have, you need at least one border router that makes you the connection from the thread network to your standard backbone. So this is done on IPv6, but the thing is, KNX IP works on IPv4, so you need to do also a translation between IPv6 and IPv4, and that's what the KNX IoT router is for. So this component you also need, but you don't need a physical component in addition. That's actually service, and if you do it clever, it should be possible to also implement that on a device. Let's see your thread border router, for example. So this saves a lot of costs. At the moment, as far as I know, there's only one existing physical device that's a KNX IoT router. That's from Cascoda. And it's based on OpenWRT and gives you that opportunity. So for the reasons why we ended up with KNX IoT, the most of the points I already got you. So the other thing is that the KNX twisted pair stacks were only for a few MCUs, and they are very old normally, and they're mostly out of date. So we already had ESP32s in the portfolio, and that's why we wanted to use them. And there also is this open thread implementation already there for the ESP32s, and there's also a thread border router already there. You can buy an open thread border router test platform for around 10 euros. So there you get an ESP32S3 and you get an ESP32H2. And the second one works as a radio controller, as a companion module, which you just plug into your normal MCU, and you already have your thread working, if the stack is there. So when you look at the KNX IoT stack, so you need to make sure that for your platform, you are going to implement all the components are there. So you need the whole stack. And when you look at the stack, at the bottom, you have the physical layer. So this can be either Wi-Fi, thread, or Ethernet. The important part is that it's abstracted from that. So Cascoda, as a company, made the implementation of the official KNX IoT stack that was paid by the KNX Association, as far as I know. And so Cascoda implemented the full layer that you see here. So the thing is, the IPv6 layer, as I told you before, is standard and almost always in all of the microcontroller systems. So that's tackled. So is UDP. The next layer is MDNS and DTLS. The important part with MDNS is that you want to do multicasts in your mesh network, and that you are able to detect which services your IoT devices can provide. So this is very interesting, and this is new. And so it's important that you have MDNS running and actually also DNS-SD for service discovery. And that's also there on the ESP platform. So good for us. The next layer, when you look there, if you want to transport packets between your IoT devices, you want to have a very small packet and you want to have a standardized way. Good for us. There also is an RFC. That's the co-op. So you have here a constrained application protocol. That's what the name comes from. And this gives you the opportunity to take your messages and then send them over the layers below them. And to do that, you normally serialize the messages before in the data structure. And that's what CBOR gives you. So at the end of the day, when you decode the CBOR message, you normally get something like a JSON file. And with a JSON data structure, we can work. So that's what that stack gives you without thinking about KNX IoT. And honestly, we thought of, hey, we take that, but we are not sure if we should take the KNX IoT stack completely. But to be honest, the far more we looked into how KNX IoT did the upper layers, like the application layer and the mandatory resources, it's a lot of work to do. And KNX is there for a very long time. So KNX is a player in that market for a very long time, and the devices are there for a very long time. So KNX has built an ecosystem that is very robust. So what we are doing right now is we try that we can take all the existing KNX data points and function blocks and use it for our application, and finally end up with a device where we can use the complete KNX IoT stack and don't need to implement that kind of stuff. The good thing about an open source solution is, if we run into a problem and we see that we can't use all the functions we want to implement in our products with the existing KNX IoT solution, we can add that part. But it's enough to add only that part and don't implement the whole stack. If I have it correctly in my head, it's about 30,000 lines of code, which is the KNX IoT stack, and that's a lot. So you need to test it, you need to implement it. It takes a lot of time. So I'm very grateful that this is here now and that we can work with it. So when you look at the KNX IoT stack implementations, just one back, the lowest one, there's a porting layer. So that means the Cascoda stack is built in a way where everything is independent of the operating system you're using. But there's a porting layer where there are a couple of functions, it's around 300 lines of code, which you need to implement for your operating system. And Cascoda did that for Windows and for Linux. So you have two implementations there that's done by Cascoda, but not for our precious microcontrollers. So we need our microcontrollers, and we want our microcontrollers to also work with KNX IoT. So when you look at the open source world and you want to do it the open source style, then you basically have two options. That's Cypher and FreeRTOS. Both are decent and good open source real-time operating systems for embedded systems. So what you need to do is you need to port this OS abstraction layer to your operating system. So as already said, Cascoda did that for Linux and for Windows. The thing is that port is TCP based. And as we learned before, Thread is UDP based. So we can't use that one. So we need to look a bit closer. And then there came Nordic. Nordic is also producing MCUs. They are known for the very low power and efficient MCUs, which is great. And Nordic stepped in and did a port to Cypher, which is great, which I really like to use. And I really liked it. And the implementation is good. And it's very compact. So let's take it. The one thing is it's only UDP and Thread. But since we want to do Thread anyways, that would be okay. They also didn't use the very last version of the KNX IoT stack, but it's also not a big problem. I think this could be implemented and it's not a big deal. So Nordic added the Cypher port for their MCUs, which is pretty fair and it was pretty okay. The only problem is they added a license which states that this port may only be used with Nordic MCUs. And from my point of view, this is a very bad solution. Because the thing is, since the port is not only for Nordic chipsets, it's for the whole Cypher ecosystem. And Cypher runs on a lot of MCUs. So this would block the whole MCUs that could run Cypher. So I hope that Nordic is changing that back to the Apache 2 license, which the whole other stack is. And it's to get an idea, the whole Cascoda stack is about 30,000 lines of code. And the port to a specific platform is around 300 lines of code. So the thing is, when you get a FreeRTOS implementation, you also get Arduino. So Arduino is well known, but I personally would not advise to use Arduino for bigger projects. There are things like resource locking and things like threading, multi-threading. So it's better to use another solution. Which brings
Alex, 5 minutes, 5 minutes.
Yes, it's okay. So which brings us to the solution we are doing. We are going to use ESP32 on FreeRTOS. And the port is also not so complicated. So I started to do it and it's not finished, but we're getting there, and I hope over the next weeks, we will finish that port. So for other hardware options, you have the Cascoda Chili modules, the Nordic NRF chips, and you have the ESP H2 chip, so which we are going to use. And so that we can use that, we need to implement it in our system. And so I went there and I did an implementation for such a module. And I called it Open Source Embedded Systems Module Interface. The thing is, it will be free. It's open source. And it's based on M.2 KE interface. So the thing is, there already have been some open source approaches to that. One is from SparkFun, it's Micromod. So I basically took that and looked into it and modded it and made it more suitable for what we are doing and tried to get everything under one hood. So here you have the pinouts, but because of the time, I think you just better look at it. The thing is, there is the standards you need. You have an 8-bit parallel bus. You have SPI. You have I2C. You have I2S. So you basically get everything you need for an embedded device. You also get 2 serial ports and CAN, and also USB. That's important because USB is coming more and more. So I tried really to cram everything in that could possibly be needed. So, and the next thing is then we built the module. So I did a module for that. And we also decided to do that for free. And we will also release that. So I did a module here. That's a minimal module where I just have this module. To get an idea of this, this is just 22 millimeters wide and 25 millimeters height. That's it. Yeah. It's very easy here if you have just an LED, but it gets more complicated if you do it in a way that you put your radio controller on there, which I did. So this is the module we are going to implement, and Passive Energy will sell that module for a cheap price so that everyone can step in. And I really want to have a community that's working on FreeRTOS, and we try to provide the modules and hope that everyone is on board. So that's the radio coprocessor module, and on top of that, you also threw in an humidity and temperature sensor and that kind of stuff. So the costs were not too low, but we tried to gain attractivity for other companies who want to implement that. So that's how we are doing it. So the last thing, for that, we need a community, and we need the KNX community to discuss stuff. That's why we also set up a Discord server, and everyone is welcome to join there. There will be 2 areas, one for users and one for companies. In the user area, everyone is welcome. We can discuss everything, but sometimes companies also want to discuss things not in the open. So we also have closed source groups here where companies can communicate with each other, and I hope we can grow the community. And thanks for the talk, and hopefully next time with more time. And yeah, thank you for giving me the opportunity to present it all to you, and I hope you can gain something from it. Thank you.
Okay, Alex, thanks a lot. We are literally running out of time. I just want to thank you for your own experience with the open source stack, your opinions, your comments. We can only encourage the community to use the resources available. The main pillar is the open source stack, and that all the options end up following the certification scheme. So we hope that with your experience, you showcase what can be done with KNX IoT. And thank you very much for sharing your journey.